Look down at your hands for a second. Uh, Wiggle your fingers. You feel completely in charge of that movement,
Yeah,
right?
you form the thought, you send the command, and your hand obey it.
Exactly. You feel like the CEO of your own body.
Hmm.
But what if neuroscience could actually prove that your brain started the chemical process of moving those fingers, like milliseconds before you even realized you wanted to move them?
Right, which completely upends everything.
It does. I mean, are you actually making choices, or are you just a passenger watching the steering wheel turn by itself? You know, taking credit for a journey planned entirely by the carbon-based chemistry of your brain. Welcome to this deep dive. Today, we are taking on a massive question. Do you actually have free will, or is your conscious self just an illusion generated by biology?
It is arguably the most unsettling question in both science and philosophy.
Totally. And to navigate it, we have an incredible source today. It's a 2015 philosophical conference paper by Tennyson Samraj titled Carbon-Based Brain, Consciousness and Choice.
Yes, and Samraj is really attempting to bridge a very difficult gap here between, modern hard neuroscience and the existential philosophy of what it actually means to be a person.
Our mission today is to figure out if your conscious self actually calls the shots. Okay, let's unpack this. Before we can even begin to figure out if your self has the freedom to make choices, we sort of have to figure out how a conscious you emerges from a pile of atoms in the first place.
Right, the origin problem.
Yeah, because at a fundamental molecular level, you are made of the exact same carbon, hydrogen, and oxygen as, like, the chair you are sitting on.
Exactly.
But the chair doesn't have a crisis of identity, and you do. So how does inorganic matter suddenly wake up?
Well, science still struggles to pinpoint the exact mechanism of that transition. But we do know that when matter organizes into an organic structure, it begins to exhibit radically different properties.
Right, like it metabolizes energy, it grows.
It replicates. And as nervous systems develop, it begins to show organic sentience. A basic organism reacts to stimuli. It recoils from heat or moves toward light. And today, with functional MRI scans, we can look inside a human skull and map the exact neural states that correlate with those physical reactions.
But mapping a neural reaction to a hot stove isn't the same thing as mapping a self, is it? I mean, a lot of living organisms react to their environment, but they don't necessarily have an internal monologue.
No, they don't.
Mm-hmm.
And that is the crucial dividing line. The paper introduces a concept from a philosopher named David Rosenthal to explain this. He distinguishes basic organic sentience from something he calls state consciousness, or existential sentience.
Existential sentience, okay.
Yeah. It isn't just about processing sensory input. It is the unique awareness that you are conscious. It is the system basically observing itself.
Wow, okay. Which brings to mind, the most famous philosophical starting point in history. Descartes sitting by his fire, doubting everything in the universe until he realized the very act of doubting proved he existed.
Right. I think, therefore I am.
Exactly. But given what we now know about fMRI scans and the absolute biological necessity of the brain, should that be modernized? Like, if existential sentience is inextricably tied to neural states, shouldn't the mantra now be, I have brain activity, therefore I am?
That's a great point, and the paper wrestles deeply with that modernization.
Yeah.
Paul Bloom, who is a psychologist referenced by Samraj, argues that the physical, genetic, and neural you are not alternatives to the conscious you.
Okay.
They are the absolute foundations. The conscious self cannot exist without feeding off human neural activity. However, and this is where Samraj introduces a really vital philosophical nuance, even though consciousness requires the physical brain, it cannot be entirely reduced to it. It is what he calls a non-reductive given.
Non-reductive given. Okay, that sounds incredibly dense. Let's break that down for the listener. If it comes from the brain, why can't we just reduce it back to the brain?
Because of how emergence works in physics. Samraj uses a brilliant distinction here between visible and invisible emergence.
Okay, give me an example.
Think of water. You take 2 hydrogen atoms and 1 oxygen atom. Individually, they are just gases, but bind them together, and they create a completely new property, liquidity.
Right. And that is a visible emergence. You can see the wetness, you can measure it.
Exactly.
But consciousness doesn't work like that. You can't just open up the cerebral cortex and find a puddle of self pooling in the corner of the frontal lobe.
Precisely. Consciousness is an invisible emergence. Samraj compares it to gravity.
Oh, that's interesting.
Yeah, you cannot put gravity in a jar, and you cannot isolate a gravity particle under a standard microscope. But we know that wherever there's a sufficient mass of matter, gravity just emerges as a fundamental force.
So you cannot reduce gravity to just one of the rocks that makes up a planet, yet the planet as a whole generates it.
Exactly. And similarly, wherever there is a specific, highly complex arrangement of neural activity, existential sentience emerges. It is generated by the physical, but operates as its own completely distinct phenomenon.
Okay, so we have this invisible gravitational field of the self, but does anything else have this? I mean, if it's just an emergent property of biology, do other animals experience it?
This is where the source brings in Thomas Nagel's famous 1974 thought experiment. What is it like to be a bat?
A bat, right.
Yeah, Nagel chose a bat because they are mammals. They are clearly alive and sentient, but their subjective experience of the world, navigating via echolocation, essentially seeing with high-frequency sound, is completely alien to us.
Right, so we can study the auditory cortex of a bat all day in a lab, but we'll never know the actual internal feeling of bouncing sound off a moth.
Yes, but Nagel goes a step further. He argues that the bat itself only knows what it is like to be a bat if it possesses a phenomenal self.
A phenomenal self, meaning what exactly?
Meaning there is a subjective internal theater where the bat actually experiences its own existence. Samraj builds on this by suggesting that without that existential sentience, a bat, or really any organism, is functionally just a highly complex biological thermostat.
A thermostat.
Yeah. A thermostat detects a drop in temperature and turns on the heat, but it doesn't feel cold. It just executes a programmed response.
Okay, I am going to push back on this a little bit, on this reliance on biology, because we are currently living through an absolute explosion of artificial intelligence. We have large language models that can synthesize vast amounts of philosophical data, and we have robotic systems with advanced optical sensors that can navigate physical spaces.
Right.
So if consciousness is just an invisible emergence from a complex system processing data, why can't we engineer an artificial phenomenal self? Like, why can't we code existential sentience?
It is a logical leap to make, for sure. But Samraj argues we cannot simply code it because we're ignoring the structural reality of the physical universe.
What do you mean?
We assume consciousness is just a matter of processing power. Neurons acting like logic gates in a computer. But human consciousness is entirely contingent on a specific biological scaffolding that we frankly do not fully understand.
What kind of biological scaffolding, like blood flow?
Much deeper than that. The paper points out that human consciousness relies on non-neural physical factors. Temperature, atmospheric pressure, the absolute necessity of sleep,
Oh, wow.
the exact chemical balance of oxygen and nutrition.
Mm-hmm.
These aren't just the fuel that powers the brain's battery. These physical laws literally shape the chemical reactions that allow the emergent field of the self to exist.
Right. And a silicon chip operating in a server farm somewhere does not require sleep.
Exactly. Nor does it care about atmospheric pressure to facilitate gas exchange in its cells. Because a machine is not bound by the thermodynamic realities of biology, it cannot generate the specific biological emergence we call existential sentience. It might simulate the output perfectly, but it won't actually possess the internal experience.
Here's where it gets really interesting. If we can't build a machine with consciousness, it forces me to wonder how much of a biological machine we actually are. Like, if human consciousness is this highly unique, irreducible field that emerges from biology, what is its actual function? Is it making the decisions, or is it just sitting in the executive suite rubber stamping decisions that the biological factory floor already made?
That question brings us directly to the neuroscientist Benjamin Libet. In the 1980s, Libet conducted an experiment that just sent shockwaves through both neuroscience and philosophy, seemingly proving that free will is a complete illusion.
Walk us through the physical setup of this experiment. How do you even test free will in a lab?
So Libet hooked human subjects up to an EEG machine to monitor their brainwaves. He placed them in front of a specialized clock with a dot moving very quickly in a circle.
Okay.
He gave them a simple instruction. Flick your wrist whenever you feel the urge to do so, and note exactly where the dot was on the clock the very millisecond you felt the conscious desire to move.
So he is trying to map the exact timeline between the mental choice and the physical action?
Exactly. But the EEG revealed something devastating. The brain exhibited a massive spike in neural activity, which Libet called the readiness potential, about 300 to 500 milliseconds before the subject reported feeling the conscious urge to flick their wrist.
Wait, hold on. So if I decide to reach for my coffee right now, my neurons already initiated the go signal and began organizing the muscle commands like a third of a second before I even knew I wanted coffee?
According to Libet's data, yes. The unconscious physical brain starts the process. The conscious mind shows up a fraction of a second later, becomes aware of the urge, and then falsely assumes it was the author of the action.
That is genuinely terrifying.
It is.
If my excitatory neurons, the ones pushing the gas pedal to initiate action, are firing before my conscious mind is even in the loop, then I am not making any choices.
Right.
I'm just a conscious observer trapped in a biological machine that is running its own program. I'm not the CEO setting the company strategy. I'm just the PR department writing a press release for a decision the factory already made.
What's fascinating here is how Samraj takes Libet's own data and completely dismantles that deterministic conclusion.
Really? How?
He argues that Libet fundamentally misunderstood the architecture of consciousness. Libet assumed that the conscious will only exist at the specific, isolated moment you decide to flick your wrist.
Which seems intuitive, doesn't it? The urge appears, so that must be the moment consciousness acts.
It is intuitive, but Samraj argues it is incorrect. Consciousness is not an event. It is not a spark that flashes only when you move a muscle. Consciousness is a continuous state of being.
Okay.
It is the overarching disposition of the mind. Therefore, the state of being conscious structurally precedes the readiness potential.
I think I see where this is going, but break down the timeline for me. How does the state of consciousness defeat the fact that the neurons fired first?
Go back to your CEO analogy.
Okay.
The CEO creates the corporate culture, sets the parameters, and opens the factory. They provide the environment where the factory floor can even operate. The irreducible conscious self provides the environment where a readiness potential is even possible. When the subject sits down in the lab, their conscious self agrees to the parameters of the test.
Oh, I see.
So what Libet measured the specific urge to flick the wrist was merely the physical execution of a broader, already established conscious disposition.
Okay, I follow the logic that consciousness is the environment, but we still have a mechanical problem here.
What's that?
Even if the CEO opened the factory floor is still pushing the gas pedal on specific actions before the CEO is explicitly aware of them. If the impulse to act starts without me, where is my actual freedom?
Your freedom exists in the second half of the neural equation, which is something Libet himself discovered but is often completely overlooked. It relies on inhibitory neurons. We possess what is called the conscious veto.
The veto, meaning I can hit the brakes.
Yes, the unconscious brain might generate 100 different readiness potentials a day. Your biology might push the gas pedal based on hunger, anger, or just a random neural misfire. But the conscious mind, which is continually monitoring this environment, has the final say before the action is actually executed. It has a window of time to look at that ascending neural impulse and just say, no.
Okay, I have to challenge that mechanically.
Go for it.
If the original impulse to hit the gas pedal was generated by an unconscious neural spike, wouldn't the impulse to hit the brake pedal also just be another unconscious neural spike? Aren't we just trading one biological reflex for another and calling it a veto?
It is a totally fair challenge, but this is exactly why Samraj emphasizes that consciousness is a non-reductive emergence. The veto isn't just an opposing neural reflex.
Why not?
Because the phenomenal self has an awareness of its own existence and its future. It can evaluate the unconscious impulse against abstract concepts like morals, long-term goals, or social consequences, which simply do not exist at the level of basic neurochemistry.
I see.
The brain offers the impulse. The emergent mind evaluates it.
You know, the paper uses an analogy here that I think perfectly crystallizes this dynamic between impulse and veto. It asks us to picture a student taking a final exam.
Right, that's a great one.
That student is trapped in a web of massive constraints. There are environmental forces keeping them in the room. There are intense social and cultural expectations from their family forcing them to succeed.
And internally, their neural chemistry might be flooding their system with anxiety.
Exactly. Generating a massive readiness potential screaming at them to run out of the room.
Because the constraints on human action are immense. We are never making choices in a neutral vacuum.
Right. But despite the weight of all those constraints, the social pressure, the genetic disposition, the biological anxiety that students still possesses, the conscious veto, they can sit down, stare at the blank exam paper, and simply choose not to write a single word.
Exactly. They can veto the entire cascading system of pressures.
The forces acting upon us are overwhelmingly real, but the existence of the conscious veto proves our freedom. We don't just passively experience the world. Our conscious self actively pushes back against it.
And this brings us out of the realm of theory and into the harsh reality of human society.
Yeah.
Because if we don't possess that veto, The foundational pillars of our civilization just crumble, particularly the law.
You are talking about the courtroom dilemma outlined in the text.
Yes. Think about the legal concept of mens rea, which translates to guilty mind.
Right.
For a massive portion of the justice system, it is not enough to prove that a person committed a crime. The prosecution must prove they had the intent to commit it.
Which creates a fascinating loophole if you take a strict reading of Benjamin Livet's experiment. Imagine a defense attorney standing in front of a judge, holding up an fMRI scan.
Oh, absolutely.
They argue, Your Honor, my client's excitatory neurons initiated the violent action 400 milliseconds before his conscious mind was even aware of it. His biology forced his hand before he could form intent. He lacks mens rea.
And if antecedent causes, meaning our genetic wiring, our childhood environment, or a specific readiness potential in the brain fundamentally determine our actions, then personal responsibility is just a biological fiction.
Right.
No one is guilty of anything. They are just acting out a chemical script.
But if we let people legally blame their neurons for their actions, doesn't all of society collapse? I mean, we would have no logical basis for justice, no justification for punishment, and absolutely zero foundation for interpersonal trust.
If we connect this to the bigger picture, Samraj argues that society survives because it relies on the phenomenological reality of human existence.
Meaning our lived experience.
Exactly. The lived, everyday experience of being human is that we are conscious of making choices.
Mhm.
You experience yourself as a free agent, and you navigate the world assuming others are free agents too.
Right.
Even if an action has deep, complex neural precursors, the presence of the conscious veto means you have the opportunity to stop it. And because you possess that veto power, society must hold you responsible for the times you fail to exercise it.
So what does this all mean? Let's synthesize this journey for you, the listener. It means you are not a meat puppet dangling from the strings of your own neural chemistry.
No, you're not.
You are a profoundly complex, invisible emergence. Your conscious self is tethered to the physical laws of your biology, relying on oxygen and sleep to maintain its environment. And yes, your brain will constantly generate unconscious impulses, suggesting actions before you even realize it.
You retain the power.
Exactly. That existential sentience, that phenomenal self, retain the ultimate power to hit the brakes. You are aware that you are aware, and inside that awareness is the power of the veto.
That is really the ultimate takeaway. Your decision to tune in today, to process these arguments, and to actively evaluate them is proof of your own volitional self.
Yeah.
You aren't merely a biological algorithm reacting to audio frequencies. You are choosing to synthesize knowledge.
Which brings us to the end of our deep dive into the carbon-based brain.
Right.
But we can't leave without giving you one last, slightly unnerving concept to mull over.
This raises an important question, found at the very end of Samraj's paper concerning the limits of physical replication. Let's imagine a future where genetic engineering is perfected. Scientists take your DNA and successfully clone your exact carbon-based body and brain down to the atomic level.
So I am staring at an exact physical duplicate of myself. Same neural pathways, same biological scaffolding.
Yes, they have duplicated a brain, and because it has the exact same biological setup, they've duplicated a mind capable of existential sentience.
Rhea.
However, the paper posits that they still have not duplicated you.
Really? Why not?
They cannot replicate the person or their subjective memory. Your invisible gravity, your specific phenomenal self, is entirely localized. Only the original conscious self can retrieve, recollect, and internally reflect on its own lived memories.
Wow.
The clone would have the hardware, and it would have its own new consciousness, but your self remains entirely singular and uncopyable.
Which leaves us with a mind-bending final thought. If an exact atom-for-atom physical replica of your brain wouldn't actually have your memories and wouldn't actually be the you experiencing the world, then who or what exactly is the you listening to this deep dive right now?
It's quite the mystery.
It really is. The machinery is carbon, but the ghost in the machine is entirely your own. Thank you for taking this journey with us. Keep questioning your impulses, keep exercising that veto power, and we will see you next time.